Here we are again, happy as can be. I know they're very popular, these balance experiments, so I thought I'd do another one. The question was asked, with the weights, the centre of mass above the axis of rotation, what would happen if just a little tiny bit of energy was given? I'm just going to do a little tiny bit, just a tiny bit, and it's unstable. So if I just move this end up, say like a centimetre, and let go, it doesn't take much. It wants to overturn. The other, this is for Michael. The question was asked about this: one mass below and one mass above. What happens now? In proper English, the answer is nothing. I thought it might have oscillated, but on further inspection, of course, it's easy to work out whether the system will oscillate or not. You can use two methods. You can use the centre of mass. If the centre of mass of the system is below the pivot point, it will oscillate. Like that. Just like that. Just like that. If the centre of mass is not above or below, it won't oscillate. Having them like this, believe it or not, the centre of mass of the system is through the pivot point. So that would predict that it doesn't oscillate. Also, you can use the other method of the moment, the force times the arm. The force, the perpendicular, or the vertical line, and the perpendicular distance is the same on both sides in this position, so it's stable. But if you wanted to predict whether it would be in this position, if you measured the distance from the pivot to the arm to there and to there, you would see that this is a longer arm, so that would predict an oscillation, which it doesn't. Why is that? Hang on. Yeah, sorry, this is the same length of arm here to here, so there's no net force. But if it was like that in that position, then this arm now is longer than this arm, the perpendicular to the line of force. So that would predict an oscillation. And then it goes longer there, longer arm there, until it dies out. So you can use two methods. Centre of mass, above or below the pivot point, it will oscillate. Or working out the moment, the force times the action, the force times the arm. Both ways, but two methods.